So we already talked about a ratio and saying that one way that you could write a ratio is as a fraction. With rates and unit rates, you're also writing it as a fraction, but a rate is just a ratio that's comparing two numbers, two values that are different units of measure. So like, you know, miles and hours or price in pounds, that kind of thing. They're different. So it's, again, it's a ratio that compares two quantities, thank you, of different measures or different units. So like I said, miles compared to hours, that's considered a rate. How many miles you can travel during a certain number of hours that you're traveling. Then you've got a unit rate. And a unit rate is very common for what you guys see. You might not know it though, but you see unit rates all the time. When you go to the gas station and you're looking at the price, that's considered a unit rate. That is a price that you're spending per gallon of gas. When you are traveling down the highway, it's got a speeding sign that tells you how fast you're allowed to go per hour. That is a unit rate. So it's just a rate with a denominator of 1. Has a denominator of 1, so it's something per 1 unit. So again, we already know how to write rates. We're just writing them as ratios. What I want to see is, can you guys find them in a unit rate form? So if you're exercising and your heart rate is 675 beats in 5 minutes. I want to know what's the unit rate. How many times is it beating per minute? How many beats per minute? So the first thing that you want to do is set it up as a rate. So what has to go on top? What unit, not what number, I'm talking about a unit. Is it going to be beats or is it going to be minutes? Which one is it going to be that goes on top of my ratio? Bryant, not minutes. It's going to be beats. Look at it. It says beats per minute. That's the first value. Then that would be like 2 or a colon or a fraction bar, and then second value. So it's this per this. It's going to be beats on top, and it's going to be minutes on the bottom. So how many beats is it for the problem? Justin? 675. So I put 675 beats. You have to write your units, guys. That's important in this chapter. You have to put the unit of measure. So 675 beats. How many minutes? 5. So I put 675 beats over 5 minutes. Now I want to know how many beats per minute. So I don't want 5 minutes. I want how many? Per. Well, how many minutes does that make it then? 1. I just want 1 minute. So the only way that I can make my denominator a 1, here's the really hard part. You're always dividing by the denominator no matter what. It's real hard, right? So hard. It's very, very confusing. No matter what your denominator is, you will always divide by it. That's how you get a unit rate. It's just division by the denominator. Always, always, always. So you're dividing both the numerator and the denominator by 5. So 675 divided by 5 is going to give you 135. Now, I'm not just going to put 135. I have to put 135 beats. Have to put the unit. 135 beats over 1, or I could just say per minute. Because I know it's over 1. I know it's 1 minute. So I can just say per minute. That lets me know, okay, that's how often it's beating in that one single minute. That's my final answer. 135 beats per minute. All right, to make 4 large pizza pockets, Paul needs 14 cups broccoli, because there's nothing like putting broccoli with pizza. I personally would prefer a pineapple, but okay. Don't say ew. Raise your hand if you like pineapple on pizza.
I don't like
Pineapple's the best.
Wait, do you eat fast food like from outside?
I don't really.
I know you don't.
Huh?
I know you don't. I know it.
We make our own pizza.
Yeah,
All right. So, well, okay. I'm sorry, but I'm sure you'd rather have pineapple than broccoli, right? If you were to choose between pineapple pizza and broccoli pizza, I think I like broccoli, just not on my pizza. Don't knock it until you've tried it. All right. So if we've got 4 large pizza pockets and 14 cups of broccoli, I want to know how much broccoli does he need for 1 pizza pocket? How much is needed for 1 pizza pocket? So usually the hard part for you guys is just setting it up, knowing which value in this case would have to go on top and what value has to go on the bottom. So we're talking about pizza pockets and cups of broccoli. Which one of those has to go on top, Joel? The broccoli. Okay, so we know that the broccoli is going to have to go on top and that the pockets are going to have to go on the bottom. How much broccoli do we have? 14. So we have 14 cups of broccoli. No more sharing. Bring it back. Over 4 pizza pockets. 14 cups of broccoli over 4 pizza pockets. Now again, here comes that real hard part. What are we going to divide everything by? 4. We want to divide by whatever our denominator is. So we're dividing it by 4. And that's going to come out to 3.5 cups of broccoli per pizza pocket. And that's it. 3.5 cups of broccoli per pizza pocket. Yeah.
So, you know how you would always divide it by the bottom number?
Mhm.
You're always going to get one.
Mhm. It'll always be per one item.
Can you just put 1 instead of 1?
You'd have to put per whatever the item is. Or you can put it as 3.5 cups of broccoli over 1 pizza pocket. But you can say that too. Shh. All right, James. James wants to drive. 288 miles to Rainbow Falls in 6 hours. What is his average speed? Okay. So we want to know what his average speed is. EJ, I need you to stop talking. So speed, what ratio is speed? What over what? Think about the units of measure. What are you comparing when you're talking about speed? Miles and hours, right? So which goes on top? Miles. And then on the bottom, hours. Okay, so we know that we're driving how many miles? 288. So we have 288 miles. How many hours? 6. So we have 6 hours. All right, Adolfo, what are we going to do? Very good. So we're going to divide by 6. Okay, so 288 divided by 6 is going to give us 48. So we have 48 miles per hour. It's pretty simple stuff today, guys. Now, the part that may be a little confusing to some people is when we get into what we call a unit price. It's the same thing as a unit rate, but unit price is where you're comparing how much something costs per a single unit, and then you're trying to see which one would wind up being a cheaper result. This is something that you actually, as you get older, you start naturally doing. Serious. You start naturally doing it because when you're looking at how much something costs and you're wanting to try to get the best purchase. So for example, my family, we go through a lot of rice. We eat a ton of rice every single day. So we usually buy, one of those big 10-pound bags of rice, and it lasts us a couple weeks. But every so often, maybe I don't feel like going to Great Wall or to, H Mart to go get it. So I might go to Publix. Well, Publix doesn't sell a 10-pound bag, but they sell 1-pound bags of rice. They sell 2-pound bags of rice, and they sell 5-pound bags of rice. Well, so now I'm looking at it going, okay, well, which one's going to be the better deal? Meaning which one's going to cost me the least amount of money in the long run. So obviously, if I'm just worried about what I'm going to pay right now, the 1-pound bag is going to be cheaper, isn't it? It's a smaller amount. It's going to be cheaper. But if I'm wanting it to be something that I know I'm going to have to use all the time, then I might not want to go with the smallest item. I might need to go with something bigger because it might be cheaper in the long run. So then that's when I start comparing, well, how much, I know 1 pound is going to cost me $1.39. And then maybe 2 pounds is going to cost me $2.60. And then 5 pounds is going to cost me $5.92. Well, then when I look at it, I'm going, okay, well, which one might be the cheapest one? In the long run, price per pound, the 1-pound bag is actually the most expensive. The 2-pound bag is the cheapest. Because I'm looking at how much does it cost per pound. And a 2-pound bag is cheaper than a 1-pound bag. So even though up front it's more expensive, in the long run, because it lasts me longer, it's cheaper for me to buy a bunch of that than it is to buy a bunch of 1-pound bags. Okay? So that's something that you'll be doing as you get older. You do comparative shopping. Now, the nice thing is Publix and a lot of other grocery stores have now started doing it. The next time you go to the grocery store with your parent, if you happen to go, look at the tag, the barcode that's on the shelf. And if you look at it closely, it'll tell you a price per unit. So it'll give you something like 0.007 cents, even though there's no such thing as 0.007 cents, but they're giving you the unit rate per unit, per ounce or per pound or per fluid ounce. So that way you don't have to sit there and calculate it like we used to. They now give it to you and you can comparatively shop and go, oh, okay, this is a cheaper unit price than this one. And since I know I'm using this all the time, I want to go with a cheaper unit price. Yeah. Huh? We just calculated it. It's something you just do quick in your head. You know, my mom used to take a calculator with her to the grocery store. I always remember thinking, oh God, this is so weird. But then you'd look around and all the moms are like calculating with a little tiny miniature calculator. Yeah, my parents were coupon mummies. Huh? Yeah, the unit, right? It's smart. Shh. All right, quiet. So let's say we're talking about lemonade prices. So you've got the size of lemonade and you've got the price for the lemonade. And let's say that I have a 12 fluid ounce glass of lemonade is going to cost me, I will say, 99 cents. And then I've got an 18 fluid ounce. That's going to cost me $1.69. And then I've got a 24 fluid ounce. That's going to cost me $2.02. And I want to know which one's going to be the better deal. So again, if I'm only worried about the immediate price, then I'm going to go with the smallest item. It's the cheapest one. But if I'm looking at long term, if this is something that I'm always going to be buying for my family to use and to consume, then I need to look in the unit price of it. Now, the way that you find the unit price, you have to take the price. This is where people make a mistake. You have to take the price and divide it by the amount, the items. That means for here, I'm going to take 99 cents and I'm going to divide it by 12. 99 cents and divide it by 12. And that's going to give me a unit cost of 0.0825. Now, obviously, that's not true money, is it? But for all intents and purposes, I don't want to round that yet. Because there's a possibility that if I round this, if I say, oh, it's 8 cents, and then I do it with something else, it might also round to 8 cents. And then how would I know which one's cheaper? You have to look at it in its raw form. When you are comparing, you compare the raw form. Jalen, second time I'm asking you to take you off your hood. Okay, let's do the same one here. We're going to take $1.69 and we're going to divide it now by 18. When we do that, we're going to get 0.0938, and that 8 is going to keep repeating. So based off of these two so far, which one's cheaper? The first one, right? 0.08 is cheaper than 0.09. Okay, so right off the bat, I know that this is not going to be the cheaper one. Okay, then we're going to go on to the next one. Let's say $2.02. We're now going to divide it by 24. So 2.02, and we're going to divide that by 24. And that's going to give us 0.0841, and then that 6 is going to repeat. So again, we have two values that are 0.08. So which one's cheaper? The first one, because it's 0.082. This is 0.084. So 0.082 is cheaper. So in the long run, this 12 fluid ounce is going to be the cheapest. You're just taking the price and dividing it by how many units here there are. Maybe it's ounces, maybe it's pounds, maybe it's, boxes. It's always going to be price divided by item. Well, I didn't divide 12 with 18. I did 99 cents divided by 12. Okay. All right, one more example. So let's say that Ryan can type, see here, 66 words in 3 minutes. Ryan can type 66 words in 3 minutes. It's a very slow typer. So I want to know how long will it take him to type 363 words? It won't. So if he can type 66 words in 3 minutes, I want to know how long is it going to take him to type 363 words. So what you're going to be doing here, you're given a rate already. 66 words in 3 minutes. That's a rate. So if I want to set this up, I can set it up as 66 words over 3 minutes. Now I want to find an equivalent rate to this, but not just any equivalent rate. I want it to be equivalent to 363 words, but I don't know how many minutes. So what do I put when I don't know a value? Not a question mark. X. You guys got to move away from those question marks. You need to move into variables. So it's X minutes. This right here, guys, is called a proportion. You set up a proportion. Information that you know and information that you want to know. Information you know compared to information that you're wanting to know. Bryant, turn around. So in order to, Bryant, turn around. In order to solve this, you do what is called a cross product. So for the cross product, you're just going to multiply your diagonals. Make sure you're really paying attention here. So we're going to multiply 3 and 365. That's what I just said it's called. Hence the reason I wrote a proportion right here. 3 times 363 is going to give me 1,089. And then on the opposite side, I'm also going to multiply 66 times x. So what is 66 times x? 66x. And now to solve it, in order to solve it, to get x by itself, to find out how many minutes it's going to take, all I have to do is divide by 66. So I would get that x is going to equal 16.5 minutes. So it's going to take him 16.5 minutes to type 363 words. This is the stuff that you're doing today on your assignment. You do have a worksheet that you need to complete today. It's due tomorrow.